Hello and welcome back. Today we're gonna continue my cloud architect learning path. I will continue in particular this course here, the number 7, reliable Google Cloud infrastructure, design and process. Let's resume the course. Let's go.
In this module, we discuss
Hey. So yeah, in this module we'll discuss choosing how to choose a storage solution. And this is the module overview. Let's go.
In this module, we discuss Google Cloud Storage and data solutions and how to select the most suitable one to meet your business and technical requirements. Google Cloud provides a rich set of different storage options that cater to different types of data, sizes of data, life cycle, and also data access patterns. We will discuss storing binary data with cloud storage, relational data with Cloud SQL or Spanner, and NoSQL or unstructured data using Firestore and Bigtable. In addition, we will consider caching for fast data access using memory store, and finally aggregating data for queries and reports using BigQuery as a data warehouse.
Nice. So this will be a purely theoretical module.
Let's get started by considering key storage characteristics. Google Cloud has a wide range of managed storage and database options in its portfolio. Knowing the characteristics of each and being able to select a suitable solution is vital as an architect during the design process. From a high level, the services range from relational, NoSQL, object storage, data warehouse, to in-memory. These services are fully managed, scalable, and backed by industry-leading SLAs. Making a decision on which storage solution is right for your requirements is a balance of a number of characteristics, including the type of data, scale, durability, availability, and location requirements. We will discuss ways in which you can make the best decision based on your requirements in this module. Different data storage services have different availability SLAs. For a service, the availability SLA is often dependent on the configuration of the service. For example, for cloud storage, as the slide shows, the availability varies depending on whether multi-regional, regional, or cold line buckets are created. The same can be seen for Spanner and Firestore, with multi-region offerings higher availability than single-region configurations. This is where requirements are extremely important, as they will help inform the storage choices. The availability SLAs are typically defined per month. Monthly uptime percentage means the total number of minutes in a month, minus the number of minutes of downtime suffered from all downtime periods in a month, divided by the total number of minutes in a month. For up-to-date SLA numbers, refer to the documentation. Now, durability of data represents the odds of losing the data. Depending on the storage solution, the durability is a shared responsibility. Google Cloud's responsibility is to ensure that data is durable in the event of a hardware failure. Your responsibility is performing backups of your data. For example, cloud storage provides you with 11 nines durability, and versioning is a feature. However, it's your responsibility to determine when to use versioning. I recommend turning versioning on and having older versions archived as part of an object lifetime management policy. For other storage services to achieve durability, it usually means taking backups of data. For disks, this means snapshots, so snapshot jobs should be scheduled. For Cloud SQL, Google Cloud provides automated machine backups, point-in-time recovery, and optionally a failover server. To improve durability, SQL database backups should also be run. Spanner and Firestore provide automatic replication, and you should run export jobs with the data being exported to cloud storage. The amount of data and the number of reads and writes are important to know when selecting a data storage service. Some services scale horizontally by adding nodes, for example, Bigtable and Spanner, which is in contrast to Cloud SQL and Memory Store, which scale machines vertically. Other services scale automatically with no limits, for example, Cloud Storage, BigQuery, and Firestore. Strong consistency is another important characteristic to consider when designing data solutions. A strongly consistent database will update all copies of data within a transaction and ensure that everybody gets the latest copy of committed data on reads. Google Cloud services providing strong consistency include Cloud Storage, Cloud SQL, Spanner, and Firestore. Eventual consistent databases typically have multiple copies of the same data for performance and scalability. They support handling large volumes of writes. They operate by updating one copy of the data synchronously and all copies asynchronously, which means that not all readers are guaranteed to read the same value at a given point in time. The data will eventually become consistent, but not immediately. Bigtable and Memory Store are examples of Google Cloud data services that have eventual consistency. When designing a data storage solution, calculating the total cost per GB is important to help determine the financial implications of a choice. Bigtable and Spanner are designed for massive datasets and are not as cost-effective for small datasets. Firestore is less expensive per GB stored, but the cost for reads and writes must be considered. Cloud storage is not as expensive but is only suitable for certain data types. BigQuery storage is relatively cheap but does not provide fast access to records, and a cost is incurred for each query. So as you see, the choice of the right storage solution is not simple. It has to be based on the type of data, size of data, and read-write patterns.
Okay, so let's continue. Interesting points here, but nothing new until now.
Now define storage characteristics for each of your case study services. In a microservice architecture, there is not one big database to store everything for the entire application. Each service should maintain its own data. Storage characteristics include whether the data is structured or unstructured, and relational or NoSQL. Ask yourself if you require strong consistency, or if eventual consistency is good enough. Also, think about how much data you have, and if you need read-write or read-only. Here's an example table for an account service that specifies all the business and technical requirements that I just mentioned. Refer to Activity 6 in your design workbook to fill out a similar table for your service.
Okay, so let's open my workbook for these course exercises. And it says to do this exercise here, defining storage characteristics. Okay. On the next slide, fill in the required storage features. Okay. So these are the microservices, SLI, SLO, the stories, the personas, and the futures. Okay, so here the customer will have, my customers will have to complete this interview form service. The data which will be saved in this case are structured. This data will need an SQL database. Strong or eventual consistency, eventual is good. Amount of data, so I think it will be less than gigas. It will be just information about the people, therefore it will be mega sizes, and this service will write here. Okay, then we have this other service here which will view the customer database and will write the itinerary database. This service is called itinerary definition. The data will be structured, all SQL, all eventual, all, I will say, megabytes, and it will be right. I mean, these will access two SQL databases. I will add a column here, insert a column left, entity, here we talk about customers, here customers, and itinerary. So here I will read the customer, write itinerary. Oh shit, okay. Then we have this other service which will only read the itinerary database and will access the the multimedia service will provide some links to cloud storage, itinerary database, itinerary view mod service. I mean, for sure, customer and itinerary. It will work with structure and object. SQL. Strong or eventual consistency, eventual amount of data. Here in the first case we talk about megas. And teras, or well, let's put gigas for now. Yeah. Read customer, write itinerary. Okay, so I will just delete this row and this row and this row. Yeah, we finished, kind of finished. Of course, it's more complex in real life. Well, let's complete. Let's add a row, insert row below. This will be about analytics service. It will be data warehouse. So memorized entity. Structured or unstructured. This will be unstructured, I think. No SQL eventual. I will say megas. I mean, it depends on the amount of events. Let's say gigas to be cautious, and then read only or read write. And then we have the reporting service, which will only read this database. Okay. Not even read the data warehouse. It will already have aggregations done. So yeah, this is a good summary, really simple example, but a good one. Okay, mark as completed. Now,
In this activity, you were asked to define the storage characteristics for the case study you are designing. These characteristics will help you choose Google Cloud Storage services most appropriate for your application. Here's an example for our online travel portal, ClickTravel. We focused on the inventory, inventory uploads, ordering, and analytics services. As you can see, each of these services has different requirements that might result in choosing different Google Cloud services.
Now that you've documented the data characteristics of your services, let's talk about how to select Google Cloud Storage and Data Solutions. The Google Cloud Storage and Database portfolio covers relational, file, NoSQL, object, block, data warehouse, and in-memory stores, as shown in this table. Let's discuss each service from left to right. Relational. Cloud SQL is a fixed schema database with a storage limit of 64 terabytes. It is offered using MySQL, PostgreSQL, and SQL Server. These services are good for web applications such as CMS or e-commerce. Spanner is also relational and fixed schema, but it scales infinitely and can be regional or multi-regional. Example use cases include scalable relational databases greater than 30 gigabytes with high availability and also global accessibility, like supply chain management and manufacturing. AlloyDB is a fixed schema, fully managed PostgreSQL compatible database. It provides enterprise-grade performance and availability while maintaining 100% compatibility with open source PostgreSQL. File Store is a schemaless, high-performance, fully managed file store service for applications that require a file system interface and a shared file system for data. File Store gives users a simple, native experience for standing up managed network-attached storage with their Compute Engine and Google Kubernetes Engine instances. Google Cloud's NoSQL data stores are schemaless. Firestore is a completely managed document data store with a maximum document size of 1 megabyte. It is useful for hierarchical data, for example, a game state or user profiles. Bigtable is also a NoSQL data store that scales infinitely. It is good for heavy read and write events and use cases including financial services, Internet of Things, and digital advert streams. Object. For object storage, Google Cloud offers Cloud Storage. Cloud Storage is schemaless and completely managed with infinite scale. It stores binary object data, and so it's good for storing images, media serving, and backups. Block. Persistent disk volumes are schemaless, durable network storage devices that your virtual machine instances can access like physical disks in a desktop or server. The data on each persistent disk volume is distributed across several physical disks. Warehouse. Data warehousing is provided by BigQuery. The storage uses a fixed schema and supports completely managed SQL analysis of data stored. It is excellent for performing analytics and business intelligence dashboards. In-memory. For in-memory storage, MemoryStore provides a schemaless, managed Redis database. It is excellent for caching web and mobile apps and for providing fast access to state in microservice architectures. Let's surmise the services in this module with this decision chart. First, ask yourself, is your data structured, and will it need to be accessed using its structured data format? If the answer is no, then ask yourself, do you need a shared file system? If you do, then choose File Store. If you don't, then choose Cloud Storage. If your data is structured and needs to be accessed in this way, then ask yourself, does your workload focus on analytics? If it does, you'll want to choose Bigtable or BigQuery, depending on your latency and update needs. BigQuery is recommended as a data warehouse. It is the default storage for tabular data and is optimized for large-scale, ad hoc, SQL-based analysis and reporting. While BigQuery data manipulation language enables you to update, insert, and delete data from your BigQuery tables, because it has a built-in cache, BigQuery works really well in cases where data does not change often. Bigtable is a NoSQL wide column database. It is optimized for low latency, large number reads and writes, and maintaining performance at scale. In addition to analytics, Bigtable is also suited as a fast lookup, non-relational database for datasets too large to store in memory, with use cases in areas such as IoT, AdTech, and FinTech. If your workload doesn't involve analytics, check whether your data is relational. If it's not relational, do you need application caching? If caching is a requirement, choose MemoryStore, an in-memory database. Otherwise, choose Firestore, a document database. If your data is relational and you need hybrid transactional analytical processing, choose AlloyDB. If you don't need HTAP and don't need global scalability, choose Cloud SQL. If you don't need HTAP and need global scalability, choose Spanner. Depending on your application, you might use one or several of these services to get the job done. For more information on how to choose between these different services, please refer to the links on storage options and databases in the course resources. You might also want to consider how to transfer data in Google Cloud. A number of factors must be considered, including cost, time, offline versus online transfer options, and security. While transfer into cloud storage is free, there will be costs with the storage of the data, and maybe even appliance costs if a transfer appliance is used, or egress costs if transferring from another cloud provider. If you have huge data sets, the time required to transfer across a network may be unrealistic. Even if it is realistic, the effects on your organization's infrastructure may be damaging while the transfer is taking place. This table shows the challenge of moving large data sets. The color-coded cells highlight unrealistic timelines that require alternative solutions. Let's go over online and offline data transfer options. For smaller or scheduled data uploads, use the Cloud Storage Transfer Service, which enables you to move or backup data to a cloud storage bucket from another cloud storage provider, such as Amazon S3, from your on-premises storage, or from any HTTPS location. Move data from one cloud storage bucket to another so that it's available to different groups of users or applications. Periodically move data as part of the data processing pipeline or analytical workflow. Storage Transfer Service provides options that can make data transfers and synchronization easier. For example, you can schedule one-time transfer operations or recurring transfer operations. Delete existing objects in the destination bucket if they don't have a corresponding object in the source. Delete data source objects after transferring them. Schedule periodic synchronization from a data source to a data sink with advanced filters based on file creation dates, file name filters, and times a day you prefer to import data. Use the Storage Transfer Service for on-premises data for large-scale uploads from your data center. The Storage Transfer Service for on-premises data allows large-scale online data transfers from on-premises storage to cloud storage. With this service, data validation, encryption, error retries, and fault tolerance are built in. On-premises software is installed on your servers, the agent comes as a Docker container, and a connection to Google Cloud is set up. Directories to be transferred to cloud storage are selected in the Cloud Console. Once the data transfer begins, the service will parallelize the transfer across many agents, supporting scale up to billions of files and hundreds of terabytes. Via the Cloud Console, a user can view detailed transfer logs and also the creation, management, and monitoring of transfer jobs. To use the Storage Transfer Service for on-premises, a POSIX-compliant source is required and a network connection of at least 300 megabits per second. Also, a Docker-supported Linux server that can access the data to be transferred is required with ports 80 and 443 open for outbound connections. The use case is for on-premises transfer of data whose size is greater than 1 terabyte. For large amounts of on-premises data that would take too long to upload, use Transfer Appliance. Transfer Appliance is a secure, rackable, high-capacity storage server that you set up in your data center. You fill it with data and ship it to an ingest location, where the data is uploaded to Google. The data is secure, you control the encryption key, and Google erases the appliance after the transfer is complete. The process for using a Transfer Appliance is that you request an appliance and it is shipped in a tamper-evident case. Data is transferred to the appliance, and the appliance is shipped back to Google. Data is loaded to cloud storage, and you are notified that it is available. Google uses tamper-evident seals on shipping cases to and from the data ingest site. Data is encrypted to AES 256 standard at the moment of capture. Once the transfer is complete, the appliance is erased per NIST 888 standards. You decrypt the data when you want to use it. There is also a transfer service for BigQuery. The BigQuery Data Transfer Service automates data movement from SaaS applications to BigQuery on a scheduled, managed basis. Data Transfer Service initially supports Google application sources like Google Ads, Campaign Manager, Google Ad Manager, and YouTube. There are also data connectors that allow easy data transfer from Teradata, Amazon Redshift, and Amazon S3 to BigQuery. The screenshots on the slide show a source type is selected for a transfer, a schedule is configured, and a data destination is selected. For the transfer, the data formats are also configured.
Okay, we had a lot of informations in this video. Now I think we'll have an activity.
You will now select storage products for each of your case study services. Use these storage characteristics and your understanding of Google Cloud's various services that we covered in this module to help you choose which storage services would be most appropriate for each of your microservices. Here's an example table for an account service that should leverage Cloud SQL because we require a relational database that's strongly consistent with gigabytes of data and read-write capabilities. Refer to Activity 7 in your design. In this
Okay. So let's change the background color to yellow so we can find this exercise slide easily. Then we have these services which will need some storage services, and these three have SQL. I don't need Spanner as I don't care about horizontal scalability. This will be a small business with few users, and here I will have both Cloud SQL and cloud storage. Then the analytics will work with data warehouse. Oh, so it will be BigQuery. Okay, this is it. We need Cloud SQL, Cloud Storage, and BigQuery. Also, I'm not sure if I will need Firestore in all of these. For the analytics, I'm sure I will need only BigQuery. But for example, interview form will gather information about the users. I'm not sure if I have to save it in one of these sources and then read it with the other. I'm not sure. I will have to discover it. Yeah, because the example was here.
BigQuery is recommended as a
Is your data structured? Does your workload involve
data warehouse.
analytics?
It is big table is a requirement. Choose memory store.
Is your
in-memory
data
database.
relational?
Otherwise, choose Firestore, a document database. If your data is relational, refer to the links on storage options and databases.
Yeah, my data is relational and doesn't need global scalability. Yeah, so I will get off this Firestore thing here because my data will be the users will be related to the itinerary, and the itinerary modifications will work on this. So we have to use Cloud SQL.
Uploads. Use the Cloud Storage Transfer Service, which enables you to
Let's
move
go.
or backup data.
We
to
nearly
cloud
finished this module here.
In this activity, you
In
are
half
asked to
an
select the
hour.
appropriate Google Cloud Storage services for your case study. Here's an example for our online travel portal, ClickTravel. For the inventory service, we will use Cloud Storage for the raw inventory uploads. Suppliers will upload their inventory as JSON data stored in text files. That inventory will then be imported into a Firestore database. The order service will store its data in a relational database running in Cloud SQL. The analytics service will aggregate data from various sources into a data warehouse, for which we'll use BigQuery or database.
It's not clear to me how they chose this. Yeah, analytics, BigQuery. Okay, there's no problem there. Orders. Okay, orders. I understand. They will be Cloud SQL. Inventory uploads. I'm not sure what they mean with inventory thing here. Are they literally photos? What the fuck are they? Suppliers will upload inventory as JSON data stored in TXT files. Okay, because they're crazy. Yeah, they will maybe use just an API. Yeah, my customers will not use API. They will use a form. You are a global financial service company with users all over the world. Okay, Cloud Spanner. You need a database service that can provide low latency worldwide with strong consistency. Which service might you choose? Spanner. You need to store user preferences, product information, and reviews for a website you are building. There won't be a huge amount of data. What will be a simple, cost-effective managed solution? For a website. A website, Cloud SQL. Yeah, it looks like an e-commerce. Cloud SQL looks nice. Currently, you are using Firestore to store information about products, reviews, and user sessions. You'd like to speed up data access in a simple, cost-effective way. What would you recommend? You would like to speed up data access in a simple, cost-effective way. What do you mean with data access? For whom? Currently, you are using Firestore. Well, if you mean to the user, to the service, replying to the users, I will say memory store. BigQuery is not for this shit. Spanner is not cost effective, and Bigtable neither. I mean, they're not specifying like giant amounts of informations, and it looks like an e-commerce or something like that, so you don't need really to use Bigtable. You want to analyze sales trends, so analytics. To help achieve this, you want to combine data from your own premises Oracle database with Google Analytics data and your web server logs. Where might you store the data so it is both easy to query and cost effective? Bam, BigQuery. Let's see, 100%. Ooh, 75. Oh. Fuck. What do you mean? These could be a potential solution, but the flexibility of Firestore as a document store compared to a schema-based cloud is a better choice for the type of data, in particular for user preferences and review. Okay. Also, the scale of Cloud SQL may be a limitation for peak loads, for instance, Black Friday or Finally, pricing model is more expensive than Firestore. What the fuck do you want? Firestore again? Firestore will be the right. Yeah, okay, so I'll just continue as I passed it.
In this module, we covered the various storage services.
Your score, passing score 80%, retake, okay. You want to analyze sales trend. Store the data so it's both easy to query and cost effective. Currently using Firestore. You are a global financial service. You need a database service that can provide you low latency worldwide, blah, blah, blah. And here is Firestore, as I need to store reviews and preferences. Yay! Fuck you. Let's go.
In this module, we covered the various storage services available in Google Cloud. These include Cloud Storage for binary data, Cloud SQL and Spanner for relational databases, Bigtable and Firestore for NoSQL databases, and BigQuery for data warehouses. We also talked about different storage characteristics and how they can be used to help you choose where to store your data.
Okay.
In this module, we discuss.
Now I have completed these modules here, these 4 modules. I still need to complete these other 5 modules. Hybrid network architecture, deploying applications, designing reliable system and security and maintenance, course, resources, and blah, blah. Okay, so this is everything for today. I will close this video here. Thank you for being here again. I really appreciate